Now, think of me taking this straight edge, and now the straight edge is my paper. All right, the straight edge is my paper. Now, that's my first stick right there. That's my first stick. Now I roll it out. This is going to be the next point, right? And if I keep rolling it, that's a point. And I'm going to roll it out, and I'm going to make a lot of points. I'm going to go all the way to the edge over here, if you don't mind. Now, this is my start right there. That's my first point. I mean, the start. Now, this is one. This is my second one. This is my third one. My fourth one. 5, 6, 7, 8, 9. Now I go through there and I numbered them. Okay, you got that? Now divide every one of them by 2. Now, these numbers right here become 1. That is 2. That is 3. That is 4. Now think about putting pi behind every one of them. Okay. You're putting pi behind every one of them. Then you will notice that that matches out with what we've been doing on this circle, on this graph right here. You'll notice it starts out with 0, pi over 2, pi, 3 pi over 2, and back home is what? 2 pi. That's one time around the circle, people. So from here to there is one time around the circle. Now we're going to graph. Now, the y equals sine of x. Now, we're not going to actually graph it. We're going to what we call frame it. Now, so what I'll be saying here is make a table. Now, this is not the x that you normally think about. It is theta, a measurement of an angle. And so look at your graph or your paper and tell me what is the sine value or what is the y value at sine of 0. Come on, what's the sign there? At 0. 0. So you put a mark right there. X. All right, now what is the sine at pi over 2? Yes. Now I didn't go my vertical one yet, so let me get my vertical one up in here. And let's use for one, 2 of these. Okay? Now, so I'm going to use 2 of these for 1. So I'm going to match out about right there. Okay? Now, so what did you tell me it was again? 1. Now look at the next one. What's the next thing on our list? It's pi. So what is the sign of pi? Now put a little x right there. Now, keep going to the 3 pi over 2. Now, 3 pi over 2, what's the sign of that? Pardon? -1. So this blue is my -1. I'm going to guesstimate about, where is it? Right there? All right, then what's the next one on my list? 2 pi. Yeah, we're back home, what I call it. You're back at 2 pi. Now, young people, if you'll just join the x's or dots, per se, it's going to go up, it's going to go down, it's going to go down, and it's going to come back up. That's framing the sine graph. You're going to be asked to do that as well. But you have to realize that, people, this stops here at 2 pi, but this graph doesn't. In other words, what is it at 5 pi over 2? Well, young people, you just keep thinking about it. That's 1 pi over 2. Go around the circle. All right, that's 1, that's 2, that's 3, that's 4. So where is 5 pi over 2 going to put you back at? At the top. Now, what is that number? What's it at 5? This, yeah, up here. Now, what is it over here at 3 pi? Well, let's just keep going. You just over there where pi is. Yep, it'd be 0. Then this is what? -1. Where's this one? So the graph continues forever. I've run out of space over here to continue on. So we kind of limit it between 0 or 1 revolution. 1 time around the circle. So instead of doing all of it. But while we at it, I want you to do the other side, the negative side. I want you to look at it. Now, again, I'm going to have to extend this line on. I should have hit that. Should have hit that one. All right. Now, let's go red this time. 1, 2, 3, 4. Now, when you go in the other direction, that's -1, -2, -3, -4. Follow the same pattern. That's the first 4. Y'all see that? Now follow this with 2's. Follow that with 2's. And this would be -1, and this would be what? Now follow it with a pi behind them. Now, let's talk about the pi. Let's do pi. Now that's going to be right here, and it's going to be right there. On the lines, it'll be 0. All right, but here, let me show you this. I'd like to, hopefully y'all can visualize this string doing what I want it to do. I hope it makes sense to you. In baseball season, during the baseball season, the coach says we need to go line the field off. Okay? Now they're out there and they'll take them a string and they'll go down third base there and they'll stretch it out. Now, going down that base there's 90 foot, people, from home plate to the third base. So that string's pretty long. It's going to be way out there. Now, if the team has got that the outside marked for permanently, you just got to go from here to the first base. But you know, after coach gets the line drawn, he doesn't take the string and throw it to the side. Yeah. Now, over the years, I would watch coaches do it, or like I would do it. But I would watch people. He'd call up a player and he'd say, "You do it for him." And if that child was right-handed, I would notice he'd hold it in his left hand and wind it going up. You understand that? They would do that. Very few of them, I don't remember any of them going backwards. It was always going this way if they're right-handed. Now, when I watched a young person out there and he was left-handed and he had to start winding it up, he didn't go over. He did it back, but he did it down. I don't know. But he held it in his right hand, the right hand, and he went backwards. Well, I'd say backwards. That ain't backwards. That's just a different direction. He went down. So young people, when I'm looking at this graph and I'm going right, I'm thinking that person's right. He's going up. So to the right is up. Now, if the person's going to the left, he goes down. So what I'm getting across to you, I hope, that this first point's going to be down here. And the other one is going to be up there. Don't worry about it. Now, so when you graph it now, or you join the dots, it goes something like this. And if you look at the total graph, it's just a continual up and down and up and down. Y'all see that? No matter where you start, it's not going to be something changing on it. I hope you see something like that or understand. Now, what we do is we graph it in a periods. In other words, this is what we call a periodic chart. It just continues on. It's periodic. Goes on forever. But well, that is the sine. What's the cosine?
I'm really, really sorry.
I am sorry. It's my fault. People, we got to get something to eat. That's my fault. Sine, if you want something to eat. Hurry up now.
I'll come back in 2 minutes.
Okay. They'll have it ready then. All right. Now, the other one, I wish it wasn't in red. Now,
Oh, we got all problems.
all right. Now remember how you do it. This is 1, 2, 3, 4, 5, 6, 7. Divide every one of them by 2. Now that's going to be pi. That's going to be 2 pi. 3 pi. Now, and we're going to graph the cosine. Now, tell me what the cosine is at 0.
1.
What is the cosine at pi over 2?
0.
What is the cosine at pi?
-1.
And what is it at 3 pi over 2?
0.
And what is it 2 pi?
1.
Now people, that's one time around the circle. So the cosine, this is called framing it. Now, does the cosine stop there? No, it goes left and right, doing the same thing. You stop at 1 revolution. And that's the cosine. Now, I'm not going to deal with the tangent and cotangent just yet because there ain't nothing similar to what I just showed you. And so we got to deal with that like that. Now what I want to do is emphasize some things that happens. Now, hopefully that accomplishes it. Now, what happens if not? Young people, I only ask you to frame a sine graph. I want you to know how to frame a cosine, but I don't ask for just this. I'm gonna make some different things happen. In other words, what is now, if you put in here a 2 in front of the word sine? Now, young people, you need a straight edge if you can find one. It'll be helpful. Because I want these lines that will go left and right, I want them perfect. I want them straight. I don't want any free-handed lines. So find you a straight edge. If you don't have a straight edge, I don't know what to tell you. Now, young people, me doing this every time, making this graph like this, that gets time consuming. So I'm going to show you what we do to not so much worry about that. Now, people, we don't need a whole bunch of them. We just need from 0 to 2 pi. All right. Now, I'm going to go up and down. So you go 1. I'm going to go count them off this time. Okay. Now, what I want to know is, if you can tell me, what is the y value? Now, x is still going up to me, or theta rather. Maybe I better start using theta there instead of x, but, well, to start off, we use x because that means you get xy table. But really and truly, it's not the x like an x value. It's an angle. All right. So this is our y. Now, so tell me what this all equals. Well, the sine of theta is 0 times anything. It's still going to be right there at 0. And it's still going to be right here at 0, and it's still going to be right there. Because we got the sine graph will never really change its appearance. The sine graph starts at the origin, goes up, makes a peak, and comes down and stops right there. All the sine graphs are going to look something of that nature. You got it? What we got to figure out, and I'd like you to tell me, now this is pi over 2. This is pi. 3 pi over 2, 4 pi over 2, which is what? 2 pi. Now tell me what it is at pi over 2. Now if you look at your chart real quickly, it'll say 2, and what is that? 1. So then that y value then is equal to what? So at pi over 2, if this is plus 1, this is 2, so that means it goes up here, comes down. How far down do you think it'll go? -2. So what I want you to visualize, what effect does that 2 in front of the sign do to your graph? makes it higher and lower. Now people, when you think of height, amplitude, the height, okay? So if you turn that paper I gave you over, y'all see that first word there on the left, amplitude, number 1? That's the amplitude. So when you start graphing these, I want you to start telling me what each one of them is. In other words, you would write amplitude. You don't have to spell it out. Amplitude, you can start with M equals 2. But it's really the absolute value of 2. Okay? Now, young people, if I go and put a negative in front of this 2, if I put a negative in front of that 2, it makes everything do what? What's up there goes where?
Down there.
Down there. What's down there goes where? So your graph is not going to go up and over. It's going to go down and back. I don't do you that way. Unless I get thinking, well, you're not paying attention, so I'm going to make sure you have to do it all. Now, so, let me get that negative out. So, that's the amplitude. That's the effect it has on your graph. Now, let me see if I can get another one halfway decent up here now. Now, like I said, you don't really have to, well, I do want a straight line, so I do want these lines to be straight. All right. So let's draw one vertically. All right. Now, then we mark it off. Come back here. Mark it off. All right. 1, 2, 3. How many I got to have? 4. 4. All right. Now, let's get him out of the way. Then this is pi over 2. This is what? Pi, 3 pi over 2, and 2 pi. Now, I didn't get any marks up and down. I'm going to go back and mark up and down. All right, let's get a little closer. Back with the green. All right, I'll just go with 1. All right, now I want you to graph this one. Now, I'm going to use theta this time. Now, you can put x, either one, but when you get to talking about the Greek angles, you usually just use the Greek alphabet, not the other. Now, what I want to know is what's going to happen to my graph if I put the 2 behind the word sine. Okay? Now, here's what's going to happen, is that between 0 and 2 pi, well, let's see what, just tell me what pi. Well, that means this, people. When I'm over here doing the angle, and I put in here 0, then y is 0. That's going to be, you can check that out. But now, pi over 2 for the angle. Now, what happens if I pick pi over 2 for the angle? This is going to be the sine of 2 times theta. And theta is pi over 2. You got it? Now, so then this becomes the sine. That's what happens to my 2's. So now, instead of asking you what is the sine at pi over 2, I want to know what is the sine at what? And if you look at your chart, it's what? It's at 0. For a while ago, now what do you think is going to be at pi? 0. What's it going to be at 3 pi? 0. What's it about? Yeah.
How do you like ribbons?
It's easy word for him.
I just got ahead of myself, I guess. All I'm doing is taking this And I'm graphing this. This is the graph. Basically, I'm asking you what happens if you put 2 in front of behind it. It's going to happen. Well, we at pi. Pi is my angle. So that would be the sine of 2 pi. So what's the sine at 2 pi?
Okay, that makes sense.
But now wait a minute now. We got to get the hump, the peak. Where is that at? Where is that located?
1.
Well, people, it's like somebody took your graph a while ago and squeezed it. Squeezed it. All right. Young people, halfway is where it's at. Halfway between these two. Now, where is halfway between 0 and pi over 2? Pi over 4. Now, people, if you count just like I did a while ago with the 1, 2, 3, 4s, but be sure that the bottom number is 4. So this is 2 pi over 4. See, that's 2 pi over 4. Then this would be what? Another pi over 4. So, well, we'll get back. That's 3 pi over 4. Now this would be 4 pi over 4, which is what? All right, and this is 5 pi over 4. That's 6 over 4. And this is 7 pi over 4. And that goes back to 2 pi. You squeezed it. All right? So what is the sine of pi over 4? Well, that's the sine at pi over 2, right?
That's 0.
No, it's not 0. What's the sine at pi over 2? 1. So go up here. Now, so the graph is going to go up, down, back, up. Now it'll go up, down, up, down. Now that's 0, and that's 2 pi. Now what happens between 0 and 2 pi if this number in front of theta is 2? Come on. It's going to make how many graphs between 0 and 2 pi? Let's see how sharp you are. Let's see if you own the ball this morning. What if I change up the problem and I say, let's do this one? Now how many graphs will I draw between 0 and 2 pi? 3 of them. What if it's 4 here? You're going to draw 4 graphs between 0 and 2 pi. That's the effect that that number has on it. What if I have a number like this in front of this? What is that going to do to my graph? Goes up 2. And how many graphs are you going to have across there? Now look at that paper though. I want you to read that back of that paper. It says period. Now the period, but really is the distance you would travel to complete one sine graph. In other words, I didn't have it a while ago. Here to there is 2 pi. That's a period. Okay? That's the distance you would travel to make one complete graph. 2 pi there. But now, on this one, you go 2 of them. how far did you travel to make one complete graph? From here to here is a period. So you had two periods, you might say, across here. Well, what's the period? By definition, look what it says. It says 2 pi divided by, does it say K?
Yes, sir.
All right. Now, different books put different letters, and I sometimes get which one it is. Now, K is the number in front of the word, behind it. See, that's A, and K is the number behind it. Don't want it twice. Okay? You got to have a theta behind it. You got to have a K. So a period is 2 pi divided by K. So what's 2 pi divided by, what was our graph? What's 2 pi divided by 2? So the period is pi. So that's pi right there. Now what's another pi distance? 2 pi. Now here's the deal though. I want you to tell me when you do graph this, where are you at? I want you to tell me the peaks and the valleys. Now let's see if we can handle one. Get this paper I just had for you. Okay, look at this one. And this is how you're going to do it now. I tried to show you specifically. But look at number 1. We're going to graph this is what they call it. But basically what you're doing is framing it. You're not going to get every coordinate along the way. All right, so here we go. I want to graph y equals 3 sine 2x. Now, the first thing, you go to the side and you write the word abbreviated amplitude. Amplitude is the height of your graph. So, in this particular problem, what's the amplitude? So that means instead of going up just 1, you go up how many? 3. Next, period. Now what distance would I have to travel to make one complete sine graph? Well, you take 2 pi and divide it by 3. So the period is 2 pi over 3. Now, young people, I don't know how many of you all are pretty efficient with fractions. But if you're not efficient with fractions, you need to get that calculator back out. Now, there's another thing that I can't get it all done in one day. It's called the phase shift. Right now, you don't have one. And the other one is what we call a vertical displacement. You don't have one. So I'm not going to deal with it right now. I'm just going to get this one out of the way. Now, like I said, I would like for you to have a straight edge to draw these lines. Now, this is how you're going to do this. Now, pay attention and you will enjoy it. But now, if you don't, the period, this number right there in front of the word, after the word, that means you're going to have to draw 2 sine graphs between 0 and 2 pi. You got that? Now, sine graph goes up, comes back down, goes down. That's one sine graph. Now, you got to draw that many of them. 2 of them. Between 0 and what? 2 pi. Now, that little phrase will change if we have a phase shift. That'll be a change in the value. But phase shifts is tough. When we deal with phase shifts, now, what I want you to visualize that is 2 pi. You've drawn 2 graphs between 0 and 2 pi. Now I want to know where it crosses the x-axis. Okay? I want to know all. No, this isn't 3. This is 2 here. Period is pi, not 3. You don't divide by the amplitude. You divide by the k. This is k. That's A. You don't divide by A. You divide by k. Sorry about that. All right. So where is the go up, come back down? That's pi. That's pi. Now what is this one? Well, young people, think in terms of halves, the sign. So halfway between here and here is what? Pi over 2. And from there to there is what? 3 pi over 2. Now, the amplitude is what?
3.
So it's, the highest point is 3. So what is the coordinate there? How far out did you come? How far up did you go? Well, we went up 3, but how far out did you go? No, that'd be half of pi over 2. Pi over 4. Like I said, people have a little struggle with some of those fractions. All right, now where is this peak? Mean Valley. Well, is it -3, but how far out did you go to here? What is that? 3 pi over 4. Now, how do you deal with that? Remember, I just told you. 1 over 4. 2 over 4 is the next one. So this is what? 3 over 4. This one that's pi is what? 4 over 4. So what's this one here going to be right there? Wouldn't you not agree with that? 5 pi over 4? How high is it? Now what's that one? Well, this is 5 pi over 4. This is 6 pi over 4. So that's 7 pi over 4, and that's down here. I didn't get to I didn't put 3/4 here. All right, that's 7 pi over 4. Then -3. Now, as long as it's even numbers, it's not so bad. Now, do you see number 2 where it says -30 degrees? All right, that's the phase shift. We're not doing phase shifts. So the rest of them will have to be weighted on. Number 7 is the tangent graph. That's the one will have to be weighted on another day as well. All right? All right, well, that's